At the tail end of the first video, we were talking about positions in a matrix, and what I meant to say, just let me grab the pen, was that these entries right here, it's called the main diagonal. Those main diagonal entries, that's going to be really important going forward. So it's the A11, A22, and A33 position. Right? That's called the main diagonal of the matrix. Alright. So, yeah, let's practice with the positions in the matrix and that notation. Remember the A with the subscripts, the first number is the row, the second number is the column. So given the following matrix, here's a matrix over here, we want to find all of these entries. Let's start with A32. Right, remember, this is the third row, row 1, 2, 3, second column, A32 equals -7. Alright, let's do A21, that's the next one. Second row, first column, that's a 6. Let's do A12. Row 1, column 2, so -2. A41, fourth row, 1, 2, 3, 4, first column, gives you a -1. And the same thing, again, if it's just given as an ordered pair and you're talking about positions in the matrix, this is the row, so it's row 3, column 1, 2, 3, that's 11. Alright, so it's that easy. You just have to know the notation and then be able to read it off of your matrix. Excuse me. Oh, and down here, here's part B. All of that was part A. Part B says, what is the location of the -5 that's in the matrix? Okay, so your -5 is down here. Let's use the A notation with the subscripts and see what row that is. 1, 2, 3, 4, 5. It's row 5, and we're in the first column. So you can write it just like this, or you could write it as an ordered pair 5, 1, which means this represents the position in the matrix, row 5, column 1. Right, either or. Okay, now we're getting into the Gauss-Jordan method for row reduction. You use this method to solve a system of equations using a series of augmented matrices. And what we want, that augmented matrix in the end, to have ones along that main diagonal and zeros everywhere else. Right, except the right-hand side is going to be augmented. So we're just looking at the coefficient matrix on the left-hand side, ones along the main diagonal, and we want 0 entries everywhere else. So to do that, I'm going to use these 3 actions. These are the 3 main actions that this Gauss-Jordan method uses. You can switch rows, because if you think about this is all going to be done in an augmented matrix. But if you think all of these make sense, if you think about them as equations, alright, you can switch rows around and to try to solve an equation. That won't change the solution. Multiply or divide a row by a number that's not equal to 0. So that's just like an equation. If you're trying to solve a system of equations, we can multiply a whole row by a number, which is a whole equation by a number. We did that before. And you can also multiply a row by a constant and then add it or subtract it from another row. Add it to or subtract it from another row. Alright, so we've done all of that for like the elimination method. So all of these are going to be fair game, and what we're going to be doing is using augmented matrices now. So we've got a couple examples of this. We're going to start with a 2 by 2. This says solve via augmented matrix using row reduction. And again, that Gauss-Jordan method, it just uses these 3 actions that we just talked about. Right, so to start this method, what you do is start with that augmented matrix. So you pull off the coefficients and augment it with the right-hand side for both equations. You have to be able to write down that augmented matrix, so it's not bad. Now, as we move along, we're going to be doing some row operations, and we're going to get to another matrix, another augmented matrix over here. Alright, using these methods we just talked about. So what we want to first have is a 1 here. In the 1, 1 position, we want to be a 1. I already have one, so that's great. The next thing that you do is get that 0. You want to get that first column straight first before you move over. Don't try and change this to a 1. Don't do all your main diagonal entries first. What you want to do is column by column. Alright, so get that 1 along the main diagonal first, and then either 0 out above and below it. Alright, so I need to get a 0 here where the 2 is. And I'm going to use that 1 to do it. Alright, so to make this 2 a 0, using the 1, what I'd have to do is take negative 2 times row 1. So if I take negative 2 times this whole row 1 and then add it to row 2, and that's going to make a new row 2. Your book uses this convention. On your test, I would like you to use this notation as well, because your calculators solve these systems. They solve them very nicely. So you have to show these steps. You just absolutely have to. Alright, this is going to show me if you understand what row reduction is. Okay, so I already have a 1 on my main diagonal entry. I'm in the 1, 1 position. So I need the zeros everywhere else. So just below it right here, this 2 needs to be a 0. To get it to be a 0, you're going to always use that 1 entry in your main diagonal to 0 out the other entries. So that means I got to take negative 2 times this whole first row. You don't just do it to the column, do the whole row. Multiply by negative 2, add it to row 2, because I'm going to replace this row 2. So row 1 is going to stay the same. Alright, now I'm going to erase this down here, but this is actually what I'm doing. This row operation right here, negative 2 times row 1. Negative 2 times row 1 is this. Negative 2, it's a positive 8, and that's going to be a 0. That's negative 2 row 1. Alright, then I'm going to add row 2 to it. And this is going to be my new row 2 down here, right? If I add them, that's the 0 that I wanted. I get a 14 here and a 14 here. So 0, 14, 14. Some students write this out, you know, they have it on their scrap paper somewhere, or they write it off to the side in the margin of their test. That's fine, but I don't care to see all this. As you guys get the hang of it, you know, you'll do it in your head. But I wanted to write this out. What I do want to see is this. I want to see those row operations. So I know that you guys know how you got from here to here. Have to get the 1 along your main diagonal. That's already there. So we want to 0 out above and below it. There's only a number below it, trying to make that a 0 for step 2. So to do that, we said, okay, I got to take negative 2 times this and then add it to that. It's going to give me a 0. That's what I did down there. Now let me erase all that down there. Alright, I am not going to write that out every single time. I'll talk you through it. Alright, so look at column 1. Column 1 is straight. That's exactly what I wanted. 1 along my main diagonal. I've got a 0 below it. So now column 1 is straight. Let's move to column 2. So for column 2, I need a 1 along that main diagonal, so the 14 needs to become a 1. To get that 1, again, I don't want to mess with the negative 4 and then try and add it to get a 1 here, because I'm going to mess up my first column. To get the 1s along those main diagonals, you're always going to be dividing. Or let's take 1/14 times row 2 for a new row 2. Alright, we'll replace row 2. Divide row 2 by 14, or 1 divide by 14 times row 2. Alright, it's going to look like this. Row 1, we still haven't touched row 1. That'll change next. Alright, if I take 0 divided by 14, I'll get 0. 14 divided by 14 will be 1s. Okay, now I'm almost there. Look at this coefficient matrix. It's almost what I want. Remember, 1's along the main diagonal, 0's everywhere else, and then I'll show you how to read off those answers. Yeah, I got the 1 here already. Okay, so now this needs to be a 0 next. We just did, we put a 1 there. Made that be a 1 and we divided. So I need a 0 here. To get those zeros, again, once you get that 1 along the main diagonal, you're going to use that 1 to zero everything else out, above and below it. So what I need to do is take 4 times row 2 this time. That's where my 1 is. If I take 4 times that and then add it to row 1, so that's going to replace my row 1, and then I'll be done. Okay, so I'm not changing row 2. What I'm doing is taking, now when I say 4 times row 2, I'll write this out one more time. 4 times row 2, which is 0, 4, 4. Add it to row 1. Right, when I add those, that's a 1, that's a 0, 4. 1, 0, 4, just like that. If you need to write this out, absolutely write it out if you need to. As you do these more, you'll get the hang of it and you will not be writing those out. You can do them in your head. Alright, this is the goal. This was the goal. This is what we wanted. If you think about these equations again, this is your coefficient matrix. That's your right-hand side. So this first equation says that x equals 4, and this second equation says y equals 1. That's your answer. 4, 1 as an ordered pair. That's how you solve. That's just a little 2x2 system using augmented matrix and row reduction. What's important is the procedure that you use. You have to make sure you go column by column, and in each column, that main diagonal entry, make sure it's a 1 first. If it's not, you're just going to divide. Or actually, for the first one, if it's not, you can switch rows if you want to. If this were a 2 up there and there was a 1 down there, you could just flip-flop the rows. Get 1 in that 1, 1 position first. Then 0 out anything above and below it. Use that 1 on the main diagonal, because you're going to multiply by the opposite of that and then add to get your 0 there. When column 1 is straight, you move to column 2, get the 2, 2 position straight along that main diagonal. And so that you don't mess up column 1, all you're doing is dividing. You always divide to get the 1s along the main diagonals. Once you have that 1 in that position, then that's where you want to 0 out above and below. Always use that 1 on the main diagonal to 0 out the entries above and below it, so it doesn't mess up your previous column. Alright, and then you'll have your answer. Before we tackle this next one, I'm going to cut this video off and we'll do the next one on the next video.